Hey guys, this is your boy Preetham back at you with some more calculus, but this time we are gonna switch some gears and not do any problems, but of course I'm about to prove something that has been an important part of your calculus lives, because this is an identity that carries you through calculus. You just gotta know this identity. Of course, you know, as you can see, it's a derivative of e raised to the x, which is the same old e raised to the x. But do you know why? Of course not many of you do. I'm gonna teach you why, and like I promised, this is one of the videos I wanted to upload a long time ago. Alright, let's get started anyways. So, before I go into anything, a derivative is basically the average rate of change over time of a function, which generally happens to be of a lower degree than the original term in terms of power functions and all those functions, but it's a kind of different ballgame in e raised to the x, which I am going to show you today. Anyways, let me grab my pen real quick. There, let's go with black color today. So, a derivative of a function can be expressed as a limit. So this limit would be, the limit is delta x. That's an imaginary variable that I have that's infinitesimally small and just gets smaller as e approaches, as I want to find the derivative of e at a specific point. But this one's just for a function that is e raised to x plus delta x minus e raised to the x over delta x. I see something right now. E raised to the x and e raised to the x gotta get factored out. I just don't like complex stuff. So, gonna factor that out. E raised to the x times the limit is delta x approaches 0 of e raised to the delta x minus 1 over delta x. So now, of course, I got it factored, but now I don't know what to do with this. I can surely do something with it. And guess what that is? A u substitution. Oh, don't worry, this is not integration, where I'm just going to substitute. No, we're not integrating, but yes, we're making life easier by just doing a variable substitution. Let u equal e raised to delta x minus 1. And delta x would be equal to the natural log of u plus 1. Because, of course, if you haven't noticed already, I've just added 1 to the left-hand side and then taken the natural log to get rid of the e to find the value of delta x in terms of u. And of course, I gotta change the limit as well, because 0 belongs to delta x and not u. It's got nothing to do with u. But yeah, to find that, I'll have to just substitute my values, e raised to 0 minus 1, which has just gotta be a 0. So now, my new function, my new limit is e raised to the x times the limit as u approaches 0 of u over the natural log of u plus 1. Of course, I know what to do now. I have a bunch of stuff in the numerator and the denominator, but I don't want to be changing the function, so I'm going to do something intuitive. Multiply and divide by the same quantity, identity, whatever you want to call it. E raised to the x times the limit as u approaches 0. Now multiply and divide by 1 over u, because of course I want to get rid of the guy on top, and having a 1 over u on the bottom gives me a special benefit that you'll see later. U plus 1 times 1 over u. Now the u's get cancelled, and now my new function would be e raised to the x times the limit as u approaches 0 of 1 over u times the natural log of u plus 1. Logarithmic rules, multiplication. This 1 over u becomes an exponent of the thing that's been taken, of the function or the base. Not the base, but the function that's been natural logged. Of course, that's a word I just made up. And now the 1 over u goes up there. So let's scroll down for more room, because I won't be able to fit all of that in one place. That's e raised to the x times limit as u approaches 0 of 1 over the natural log of u plus 1 raised to 1 over u. And now, here's the benefit that I get because of that. because I know that the limit as u approaches 0 of u plus 1 raised to 1 over u is e. That's another definition of e, and that can be proven using the L'Hopital rule, which I'll be doing later, but let's just stick with the identity for now. So now I have e raised to the x times the limit as u approaches 0 of 1 over the natural log of e. Being honest, the limit notation of u does not matter anymore, because I got rid of the u's. As you know, the natural log of e is just 1, so that is just going to be e raised to the x times 1, which is just e raised to the x. And guess what that's equal to? The derivative of e raised to the x, because I just solved that. As I mentioned earlier, the derivative of the function with respect to x, e raised to x with respect to x, is the same as the limit as delta x, an imaginary variable, approaches 0 of e raised to x plus delta x minus e raised to the x over delta x approaches, as delta x approaches 0. But guess what? I've just solved this limit and it came out to be that. So from equation 1, d of dx of e raised to the x equals e raised to the x. There we are. This identity has made our life a lot easier because you don't have to go through all this. Just gotta remember, e raised to the x has the same integral and the same derivative. Thank you.